everything is code now. We're like writing code is basically deciding how the future is going to work. You're basically deciding, are we going to have personal helicopters on the roof of our house, or are we going to have like a really, really good way to meet and date sexy models? And all those things are the decisions that you're making as a programmer. Is like, what's the future going to be? We're building the future here. Almost every software development project follows a fairly similar life cycle. And there's a bunch of steps, and you can do them quickly, and you can do them iteratively, or you can do them over a period of 2 years, but you're probably going to go through these steps. Part one of a new software product or a new version of an existing software product or even a new feature is formulating the vision, figuring out what it's going to do. When we came up with FogBug 7, here's what our vision was. Our vision was FogBug 7 is going to do 3 things. It's going to be super customizable. It's going to have a plugin interface and APIs, so that's the super customizability. It's going to be much, much faster. We're going to use a different kind of compiler, and then we're going to compile to .NET CLR, so it'll be really fast. And that was number 2. And number 3 is it's going to have low-hanging fruit. And the low-hanging fruit was all this stuff that our customers are constantly asking us for. And we made a rule for low-hanging fruit. And the rule for low-hanging fruit was it has to be something that there's no easy workaround. It has to have originated from a customer request. We can't just make it up. It has to be something that customers have been asking for. And it has to be something that's easy for us to do. That's the low-hanging part. And very, very hard for our customers to work around. So if anything fits these 3 criteria, it was a candidate for FogBug 7. And it was just a way of doing a bunch of useful stuff that we thought would get us basically the most bang for the buck in terms of what development we could do. So that's the vision stage. Another way I've heard of the vision stage is design the box. And that sort of says, whatever your product's going to be, what's the box going to look like? How is it going to promote itself? What's it going to say? This will solve this problem for you, and therefore you should take this box to the checkout counter and pull out your American Express and pay $999 for it.
At Fog Creek, we believe in thinking about a feature before we implement it. And I mean a lot of things by thinking about. When we're putting a new button somewhere in the FogBug's main page or adding a new menu item, we get into these deep discussions. Every little pixel, every little thing that we change, we try to think about because we may inadvertently make FogBugs more difficult for people to use. We may make it look ugly. And a number of things can happen. And if we were to just have an idea, go ahead and code it, write the code for it, and then iterate like that, we believe that there will be a lot of time wasted versus if you were to sit down, write your ideas down. And it's difficult actually to write your ideas down in a concise form that everyone will understand. You'll end up doing this. You'll write a spec. You'll say, this is what I believe should happen. Other people will read it. Sometimes they'll misinterpret it. You'll have to go and refine your spec, rewrite it so that everyone understands. And through this process of refining and editing and making it better, you will actually, not only get consensus from other people, you'll get other people's inputs, but you'll actually change your understanding, oftentimes change your understanding of what it is that you were trying to implement.
The act of writing a specification forces you to design a product in a lot of detail rapidly using the best tool for design, which is pencil, paper, and just writing text, which is a much better tool for design than the C++ programming language and the dialogue editor that comes with Microsoft Visual Studio. I'll give you an example. You wake up in the morning and you had a weird dream, and you try to tell your coworkers at work that day about the dream that you had that night, and suddenly you realize that what appeared to be a very vivid dream, you don't actually know what happened. And so you were kind of misinformed. You thought that you knew everything about what happened in the dream, and when you try to tell the story, you suddenly realize that you're missing big gaps and you have to just make stuff up. So this is just a constant thing that your mind does, is making you think that you know more than you actually do. And because of this trick that our minds play upon us constantly and consistently, we have to overcompensate for this flaw in our brains. And that's why you write a functional specification, is to overcompensate from this weird confidence that you have that you know how to build this application or this feature. Just let's do an exercise. Why don't you write down everything you know about that thing? And as you write it, you suddenly realize, wow, I didn't think about this area at all, or I'm going to have to come up with a good way for editing the resume as well as displaying the resume, or whatever that piece of functionality is. You suddenly realize that there are big gaps, and you're going to have to make a lot of decisions. And those decisions are part of the design space that you're exploring, trying to come up with that awesome design. Let's make this a medium feature, and we'll only do the stuff that we can get done in a medium amount of time.
Okay. So at one point we just stop. Oh, it's not compiling.
How's that gonna work?
It's not compiling.
I know what's gonna happen.
We'll design something,
I know what's
we'll
gonna
cut the fat until.
But
it
I
only
just
takes
know what's
3
going to
weeks.
happen is like some of this stuff was designed as medium and it's supposed to be 2 weeks. Like what were we talking about before, the permissioning?
Yeah.
And we're like, it's supposed to take 2 weeks, and if it takes longer than that, we'll cut that part. That's sort of short-sighted to think that the developer's going to go in and be like, all right, this is 2 weeks, and then I'm going to be like, your 2 weeks is up, you're done.
What do you got?
But I already started putting all this stuff in, and then they're like, but I didn't realize that doing that would cause all this other work
That's
because now I have to go change this and because that's change
But
that.
we have the
and
magic of a spec. So you start with a spec and you write your estimates. And this is what we're going to do before anybody writes a line of code. There's a spec. You go through the spec and you make a bunch of tasks and estimates.
There's
And
still
we look at the
that's all-
estimates
even after
and we
you
say,
have
all
spec,
right,
there's
what can
still-
we remove from the spec to make those estimates less? And then we remove some things from the spec
Yeah.
until the spec is nice and trim, clean, and elegant.
Yeah.
And the estimates are down a bunch.
It's closer. They're still going to be overrun.
The main point is you don't just start developing thinking you're going to do everything and
Yeah,
then
they get
stop
the
because you're going to
rest
do.
in the stack,
You have to figure out first. In other words, nobody starts writing code until they have task estimates, and nobody does task estimates until they have a spec. And that's like you guys just have to sort of enforce
They
that.
can't do task
Just be like,
estimates
I can't start work
until
because I don't have a spec.
120913.
Or I don't have task estimates.
There
There are a few wrong ideas that people have about specs. One wrong idea that people have about specs is let's just write the code, that will be the spec. We can change the code. This is a bad way to do design. This is inefficient and this is slow because no matter how good a coder you are and how much you can change code and how confident you are in your TDD suite so that you know that you can just push a button and make sure that you haven't broken anything, none of those things mean that you can write code faster than you can draw a sketch on a whiteboard or write a paragraph in English. There's another approach that says, let's make some what they call tests, automated tests, or unit tests, and those will be the spec, and we'll do our design work by saying, well, if you call this function with these arguments, then this should be the result, and if you call that function with those arguments, then that should be the result. And some people think that that's a spec, and I've actually read books where they say you should have your customers design tests for you, acceptance tests, and then you should implement code that makes those tests happen. This, unfortunately, all programming these days, 99% of the programming that we do happens at a much higher level than that low-level unit thing. So that low level, those unit tests that you might create, the test-driven development is an awesome way to design a class. It's an awesome way to design an algorithm, to design a block of code. It's not how you design the functional program. It's not how you design your app. It's not how you design features because it's sort of too level and too precise. So if you start out by trying to create a spec by writing a bunch of acceptance tests, then again, you're working in a tool that's too difficult to work in and too slow and is not going to allow you to explore as much of the design space. And the third wrong idea I frequently heard about functional specifications is that they don't have to be written down. We'll have an oral spec. We'll just talk, communicate amongst one another. And that might work for a team of 1 or 2 people, but it's really not that good if you're ever going to hire somebody new, if you're ever going to get to larger than 2 or 3 people on your team, if you ever need to show something to the salespeople that they can show to the customers and have the customers say whether or not they like these new features. The idea that words uttered in a room are as valuable as something written down is just kind of nonsense. So if you want to take the first step of 2 people stand up at a whiteboard and explore the design space by drawing little mock-ups and talking about how something might work, that's awesome, but then go back to your room and write that down. Go back to your office and type that up in the form of a spec and do that design work because that artifact, which is often called with derision, it's often called an artifact. A spec is referred to as this accidental thing like peanut shells that are just a part of the process of getting the peanuts into your belly, which after they're used are just useless and can be thrown away. That artifact is actually kind of very, very useful thing to drive the design, and pretending that you can replace that with anything, with conversations in a room or with a bunch of acceptance tests that are automated tests written in code is missing the point, I think, of what a good functional specification should do. Okay, so before we break up for you 2 guys, what are the mantras for developers? Number 1, work in order of priority. Number 2, no code without estimates, no estimates without specs. Because we're going to go over because the specs is our only chance to trim things down enough to the tightness and the coolness that we want. Also, I should point out that we can't possibly make any more money unless we ship a new version of this freaking software. And so the longer this takes, the less money we're going to have in the excellent profit sharing of next year.
We'll ship tomorrow.
Yeah. No, this actually makes a big difference. If we're really shipping in August, that's next fiscal year. That means we get none of the benefit of all this stuff. If we can ship this stuff at the beginning of the summer, then we're going to have a few good months. At the end of the year.
Okay,
That's interesting. That's it.
Yeah.
Okay. You could have said that at the start of the meeting. This is fun.
We were trying to get a photo for the recruiting brochure, and Joel wanted something like classically New York. And so Times Square is really the best icon of New York. So we got a couple of the guys out here and took some pictures of them. So I think a lot of programmers are interested in photography. It's similar to programming in a lot of ways. They both have a creative side, a design side, aesthetic to it, but they also have a technical side. And as I've found, one of the things about photography is that the easiest way for me to improve my photography is to improve the technical side of it, to understand the balance of how light works in the camera and how the lens takes that light and what it does with it based on aperture and shutter speed and focal length. I think a lot of programmers can get into that technical side of it and use that to help promote some of their creative output and to create things that are pleasing to them visually.
My grandpa was a carpenter. And he taught me how to build stuff, and we were we'd be working on something, and he'd look at it and kind of squint. Well, it's not the way I would have done it, but probably just as good. And this is something that you find out about the other developers who work with you. There are people who will be reviewing your code, and if you didn't do it the way that they would have done it, then they will fight tooth and nail to have it done the way that they would have done it. And sometimes that's right, and sometimes it's 6 of one, half a dozen of the other. There's really no difference. So no, I absolutely don't believe that there's one right way to do everything. There are usually some very good ways and some very bad ways. The trick, I think, particularly when reviewing code, is to look at something and see that it wasn't the way that you would have done it, and to figure out if that matters or not. That's sometimes it does and sometimes it doesn't.
A surprisingly short phase of any product release cycle is actually writing new code. And what constantly surprises me is it's like 20% of a developer's year is actually writing new code. And the rest of that time is doing something else, one of the other life cycles. But writing the new code is usually relatively fast. At this phase, this is a great opportunity to have code reviews. This is a great opportunity to maybe clean up some old code that you encounter. It's never a good idea to throw away all the code that you have, especially if it works, and start from scratch, because you're really putting yourself a lot further behind than you think you are. But if you encounter a blob of code that you need to fix to do something else, and the code is just a mess or it's not highly modifiable, then you might choose to rewrite some section of the code, or to refactor or clean up or improve some section of the code that you happen to be touching. If you have working code, no matter how ugly it is, if you don't need to modify it and it works perfectly, there's no reason to ever rewrite it.
We actually do a lot more code reviews than we used to, and there are a couple things that are really good about that in a big software organization. One thing that's great about code reviews is that you learn what's going on. To a certain extent, you know what your coworkers are working on, but when you do a code review, if you do a careful code review, the kind of code review that you should be doing, then you're going to find out a lot more about what the actual technical challenges are and the kind of decisions that are being made when the code's being written, and that's really useful. they also make you a better coder. It's very seldom that that I do a week's worth of code reviews and I don't learn anything, or I don't see an approach that I would have tried.
Instead of writing all this code to check for duplicates,
I could probably just check the
number
grid
one
view.
is you could just change the table so it has a constraint on it, which is probably the right thing to do anyway.
Well, the SQL does have a constraint. It's just that it wasn't handled.
So it was
just
throwing
wasn't
an error.
Yeah.
Oh, then you just want to catch that error.
So I can just catch the exception and just say, sorry.
Yeah, so like if you comment out all this right now, let's just do that for fun. There are various levels to which you can do code reviews. The most extreme form of a code review is called pair programming, where everybody writing code has somebody sitting right next to them code reviewing consistently as they write code. And that method I found, most people are just not willing to work that way. Might work great, may not, I don't know. But it's very, very hard to get people wanting to spend their life sitting next to another programmer as they write code. So our approach is to use pair programming under certain circumstances when you have some code that needs to be written very quickly and needs to be very, very high quality, and you just don't have a lot of choices. So when you have a situation where you've just accidentally deployed something to the server and you can't roll back for some reason, and the thing that you deployed has some horrible bug, you're going to have to write a new paragraph of code to work around that bug, and you're going to have to deploy it to the server, and you got to do it in the next 20 minutes. That's a great time to use pair programming, or even triplet programming, where two people actually sit down at a computer and they're constantly thinking about it and they're reviewing each other, and it's a way to write code very quickly with very few bugs. But most people tell me they just don't really want to work that way as programmers. Otherwise, it may or may not work. The next sort of level back from that, stepping back from that, is the idea of code reviews. Of you write some code, and then somebody comes and sits down with you, and you show them that code, and you show them the changes that you make, and they give you comments on it, and they teach you some stuff, and you teach them some stuff. This is a very valuable process. The process is most valuable when you hire new people, and when you have like summer interns and stuff like that. So that's where we use it extensively.
One of the things that I noticed that really changed between my internship summer and this last internship summer, where I was working a lot with the interns, is the practice of code reviews. My intern summer, we hadn't really started that, and the interns were sort of left to code for the summer, and then only the finished project was demoed, and we just sort of did feedback based on that, but nobody was really looking at the code and making sure it was done in a consistent or intelligible manner. But we really, the summer after mine, that changed at Fog Creek. They started doing code reviews of intern code to make sure that we didn't have a situation that sort of came up my summer, where we got to the end of the summer and realized a lot of the intern code was unusable because it hadn't been code reviewed and didn't fit Fogbug's styles, or just didn't work and nobody really understood it enough to fix it, and so a lot of code had to be rewritten.
As you know, I'm Jillian. I'm a member of the QA team here at Fog Creek. This kind of session is one of the functions we perform here. We're working on Fogbugs, with which you're familiar. I'll go over the main points in the form and then we can start. So the purpose of this session is for you to help us figure out how to make this interface more user-friendly.
In a few minutes here, we're going to start doing what is hopefully the first of a series of usability tests. I'm going to be the guinea pig, and we're going to do a paper prototype kind of test where I'll sit down and be presented with a new user interface that they're working on. So the last time we did usability tests with a large group of other people was back in the first summer of Copilot. We had the people from TechSmith come in. They brought their software Moray and helped us set up this full usability test where we had people come in basically off the street, sit down with Copilot, try it out. The most vivid memory from that test was just how painful it was to sit and watch users try out beta quality software. You know, you'd be sitting in another room watching this thing live as they're fumbling around the screen trying to figure out, you know, where that button is that they need to click. And of course you know exactly where it is, so you're screaming at them, push the button, it's right there, it's right in front of you. But they just don't see it because it's not in a logical place for them. And that's the whole reason we do these tests, is that as you're working on this, as you develop an interface, you just get to know it so well that it's just obvious to you where everything should be. But it turns out when somebody sits down and starts using this, they don't have that experience, so they're not going to be thinking the same way that you do when you use the software.
Okay, so here's the paper prototype of the application that we're developing. So we've assumed that you've typed the URL of your FogBugs instance into the browser and logged in as an administrator. Okay, so you're logged in as an administrative user. Forward and back buttons, browser buttons do the same, so anything you need to do, if there's something you're used to doing, or if you need to ask, that's fine. Allison will be playing the computer. Now, Allison may seem like a pretty smart computer, but she has no speech recognition and no artificial intelligence. So she's not allowed to explain anything. If you want to do something, you need to interact with the prototype just as you would a computer. Use your finger to click on links or buttons, and anywhere there's a blue, like a sticky note, is where you can type something in.
Okay. Paper prototyping basically means you haven't built anything, but you've sketched the interface on paper, and you put the basic interface down in front of the person and say, okay, I want you to do this task. I want you to start up a new account, and then the person would point to the items they would point to that they would click on the file menu, and this way you can emulate basically a whole interface. You have dialog boxes printed out and whatever, without having built anything. And there's a fairly long tradition of this in regular software development. The main misconception I think people come to usability testing with, that I run into, is that they think it has to be complicated, that you have to do it the way it was traditionally done, as with cameras recording the person's face, so that the user's face, so you can see them struggle with the stuff and be miserable, because the idea of usability tests originally was to show the people higher up in the food chain how miserable your stuff was making people, so that they would then approve of you spending money on fixing it. So the hardest struggle I have is convincing people that it really doesn't need to be complicated. It's very simple. It's just find somebody, bring them in, have them use the stuff that you're working on, and think aloud while they're doing it.
So some of this is familiar. The list view I've seen before. But it looks like there's a new thing up here. Maybe this is the first time I came to this, or I've just set up this installation. So I've got what looks like some help boxes here.
A lot of times people, some of the stakeholders in particular, like people from marketing, will be interested in having usability give them answers for what I think of as kind of superficial problems, like layout and design. I mean, not that there's anything trivial or inconsequential about layout and design, and particularly colors, but it's just that those are usually not the major problems. The way I think of it is, I know very few people who have stopped using a website that had something that was actually useful to them and had content of interest, or an application, web app that would do something that they wanted to do, who have stopped using it because they didn't like the colors. Okay, the guideline I give people for observing a usability test is the people will always want to express opinions about things like colors in particular, because they think that you've brought them to the usability test to give you their opinion about this thing. And one of the things that everybody has an opinion about is whether something looks good or not. And so inevitably people will say something. In fact, it's usually one of the first things people say when they open up the app or the website or whatever, is they'll comment on whether they do or don't like the colors, they do or don't like the way that it looks. But my guideline for people trying to figure out what to fix is to ignore all comments that usability test participants make about colors, unless they use a word like puke, unless like 3 out of 4 people use a word like puke. And I actually had one, I don't know if I put this in the book or not, I did one test like 10 years ago, did one round of testing on an interface, and we had like 5 out of 10 people use the word puke green. It was actually, the person was a great designer, but for some reason they had made an odd choice in this particular interface. So we went in and changed it, but other than that, I would say, don't pay too much attention to it because people are just expressing an opinion because that's what they think you want them to do.
I'm guessing I don't have to hit check to like save it, so I'm just gonna hit OK.
Okay. That's it.
All right.
Thank you so much. That was very, very useful. There's a new feature in FogBugs that we are working on, and the developers had started working on it, but it didn't have a specification. So I wrote a really short spec for it, but it was the first spec that I've written here, so I wanted to do some user testing to make sure that it was going to actually do what users wanted it to do.
Jillian IM'd me about this yesterday, saying that she had a proposition for me, and that she was working on this QA test, a new feature for FogBugs, and needed someone who doesn't know all the ins and outs of FogBugs to help her out with it. I don't know a whole lot of details. I know that there will be paper involved, that this is paper-based. Not much here at Fog Creek is paper-based, at least not compared to other jobs that I've had, so that's a surprise. I really don't know what to expect. My task is to create a new user named Marilyn Monroe with the same properties as the existing user named Allison. Right, okay, so I'm logged in as an administrator, and I guess my first instinct would be I see some instructions here. Click the admin link next to your name on the upper right to configure your FogBugs site using the admin dashboard. Maybe that's relevant. Anyway, I don't know. I'm just going to click on admin.
Okay.
When you start talking to people internally and say we're going to do usability testing, they're really intent on you having people from your target audience. It's one of the things that people understand about experimental method. Okay, if we're going to be having people try using this stuff, then we want them to be people who really are representative of our target audience. And there's value to that, but it turns out there's not as much value as you would think. And it also turns out that in some cases it's a lot harder than you would think. So my motto has been recruit loosely and grade on a curve. And by recruit loosely, I mean take almost anybody you can get, or more to the point, don't let recruiting keep you from doing usability testing, okay? If you make recruiting into a big deal and you have to be really finicky and come up with a profile, a screener, and make sure that somebody's doing your recruiting in a way that you're going to get people from your target audience, then it is one of the factors that's likely to keep you from doing usability testing, or at least to keep you from doing it on a regular basis. My recommendation is people do this usability testing once a month. If you plan it and say, okay, we're going to do once a month, that's like a doable amount of time to spend on usability. And I say spend a morning a month, and you can test 3 or 4 users in a morning, debrief over lunch, and then you're basically done with usability for the month. And in that time, you will, with the 3 or 4 users, you will have uncovered enough significant problems that'll give you plenty to work on for the month. I mean, you want to focus on fixing the most serious problems.
Here I am, clone user. These new FogBugs users will have the same properties and permissions as Allison. That's what I'm looking for. FogBugs will email the users with a link to let them choose their password. Okay. Seems like I'm right where I need to be. Yeah, actually, interesting. So I think what threw me off is I was searching for something that said create new user, and it seems like the right thing to click on was the word clone, and that didn't seem intuitive to me. So I'm gonna just write in
often people, when you're doing usability testing, one of the things besides expressing their opinion, which they think you asked them there to do, that participants will do is suggest new features. They'll be doing something and they'll say, it'd be great if I could just have it put all of this stuff in one place for me automatically. I tell observers not to pay much attention to new feature recommendations by users, with kind of one exception. If a participant makes a suggestion about a new feature, and it strikes everybody in the room as a fabulous idea, and everybody in the room has the same reaction at the same time, which is, why didn't we ever think of that? That's the perfect way to do that. Then you consider it as a new feature and you talk about it during the debriefing session and kind of confirm that maybe it's feasible, and that everybody still thinks after an hour to think about it that it really is a fabulous idea. If you actually go back at the end of the test and say, I'd like to talk about that feature you suggested, can you describe to me again how that would work? And what happens 9 times out of 10 in my experience is, as they describe to you exactly how the thing that they would work, by the time they reach the end of describing it, they always say something like, but actually now that I think about it, I probably would use it the way it works now instead. That's just what happens. By the time they've talked it through, they realize that this great new functionality has its own downsides and probably in the long run isn't much better than what they're doing right now. You have to overcome this temptation to say it's too early to start testing because we haven't got enough. It turns out you can actually test very early in the process. You can show people sketches, of the interface. You can show people sketches of web pages. You can mock up stuff in HTML, or you can just show them linked screenshots online. You can get very far with very little, and there are a lot of sources out there about testing prototypes. So the earlier that you can start testing in the process, the more useful the information is, actually, because it can save you from building stuff out down lines that aren't going to work.
Sailing is interesting because one of the facts of sailing is that there's a 45-degree cone into which you just cannot sail, because the wind is basically coming directly over the front of the boat and it's pushing you backwards, if anything. And so what you actually have to do in order to move in that direction is sail at a 45-degree angle one way and then tack and sail at a 45-degree angle the other way, and sometimes you have to just keep doing that, going back and forth, getting closer and closer to your goal. And I think that has something to say for software development, where a lot of times you know what your goal is, but going directly there is too much of an upfront cost, or the goal is sometimes moving even, and what you really want to do is get moving in the right direction and then do sort of iterative improvements where you make incremental changes that are, each one is moving you in the right direction, but they're not necessarily immediately taking you to the solution. And I think that's something that I realize is important in the software development process, that you can't always do things the perfect way the first time, because sometimes you don't even know what the perfect way is. You just have to do what you think is right and be willing to revisit that decision and turn back the other way when necessary to actually get to the goal that you set out for.
Most of us have been using FogBook 7 and some guys for quite a while. The FogBooks dev team, obviously, you guys have been using it on your desk, and we've had it on our dot for a while, and it really is pretty amazing, and it's been killing me every time I go on Twitter. If you search Twitter for anybody mentioning FogBugs, you'll see 50% of the complaints are things that we already have, and we already did, code that we've already written, stuff that FogBugs already does. If you look at the, and I think the same ratio pretty much holds for people that are like, yeah, I can't use FogBugs because X, Y, or Z, and those are all things that we have really, really good answers to, and yet we're not really shipping them. So, one of the most important things that I've learned over my life is that shipping is a feature, or to put it another way, having a great product that is not shipping that is a gigantic bug. That's probably your biggest bug, is the fact that people cannot actually use the software because it is not for sale. So we're trying desperately to overcome that problem of the gigantic bug that our software is not for sale. We decided that we want to get a beta out as soon as possible, some kind of beta to some kind of customers, sooner rather than later, and work as if our hair was on fire. So Bobak is going to tell you about the plan, but the basic idea is we still want to have a great product. We just want to get the beta to start as soon as possible so that some people outside of the company can start using it. Because really the shipping time is just a function of how fast you find out about those bugs and fix them. So the basic plan is we're going to have a couple of weeks of hair on fireness that's going to end of hair on fire. That's going to end Friday, a week, not this Friday. This Friday is Good Friday. A week from after that, April 17th at 4 p.m. Like none of this like work over the weekend and come in on Monday morning and it's due Monday. We're gonna be done at 4 p.m. We're gonna have French fries. It's gonna be awesome. And we're gonna be done. We're gonna be ready to go to beta to some number of customers, either on demand or not on demand. It's just there will be customers that will have a release ready for on Friday at 4 p.m. and we'll probably roll it out first thing Monday. The term beta test is sometimes used in various different ways. There's at least 3 kinds of beta test that I've seen. Number one is when you release your product, but you're not willing to commit to the fact that it's really good enough for anybody to use. It's open, anybody can sign up for it. There's 8 billion users around the world, and you're still calling it a beta because you're kind of ashamed of bugs and you don't want people to have a high expectation of your code quality. Well, if you're doing that, you want to call it a beta, good for you. That's not what I'm talking about here. There's another kind of beta, which is just a marketing beta, and some companies will do this like a week or 2 before they actually release a product. They'll release it to a few journalists, and maybe they'll release early versions to people who have to write books about, Excel in 21 days. They'll get this thing called a marketing beta. And again, you don't really expect to get any feedback from that. It's just a way of showing the product to some people early. The kind of beta test I want to talk about is an actual test where you've taken your software and you think it's pretty good. You want to release it to a small number of people to find out about these bugs before a large number of people see it. We do beta tests here on FogBugs, and it takes us about 10 to 12 weeks to do a complete beta cycle. I've never been able to do it in less than that. And we're talking about here, in the case of 10 to 12 weeks, I'm talking about when you've spent a year writing new code and you're showing it to people for the first time. There's a lot of code, there's a lot of bugs in it, there's a lot of users. If you're releasing new products regularly, more frequently than that, if you have a website and there's a new version up there every week, then obviously your betas can be probably a lot shorter because a lot less has changed. But when a lot of things have changed, you kind of need a full cycle beta to really test it all and make sure that everybody's going to be happy with it. And for that, you need about 12 weeks.
So to keep us on focus, to get to the beta as soon as possible, we started having daily war room meetings. The purpose of the war room meeting is to gather QA, program management, and development, the leads of each of these teams together, to look at any new cases that have come up since the previous war room to decide whether we need to fix that before we go to beta. We're being very hardcore about it. We're only fixing showstopper bugs that we absolutely must fix. For example, if something came up that would cause data to be lost, then we would have to obviously fix that. But if it has something to do with a misalignment of some menu items, then we would probably punt that to the next beta, which is going to come up in about 2 weeks. So it's not a big deal anyways. Okay, so that's a bug? Okay. All right.
Distinction.
Okay, so let's put that in beta 2. And it's a bug and people depend on it, so we don't want it to be something that's not there anymore when people upgrade. So
yeah,
that deserves to be fixed.
I like it.
All right.
Yeah, I'm putting that number 2.
We're currently in the about to enter the first beta of FogBugs 7, and this is a tricky period in a software release cycle because you have to. The developers have been working really hard at making a beautiful product, but we need to pull back a little bit and say, okay, you know what? It's time to ship. And about a week and a half ago, Joel had an all-hands meeting where he described how shipping is a feature, or to put it another way, not shipping is a bug. So we've got this massive bug where we haven't shipped yet. No one's seeing all the work that we've done. So we need to make quick decisions. We need to be a little bit tough, actually, and cut some cases, some of the features or bug fixes that we wanted to put into FogBugs 7. We need to delay them to a future release just so that we can resolve that main big bug, which is shipping.
It's very important to get feedback from your users. You need them telling you about bugs. And so at some point during the application process in which you're letting people apply to become a beta tester, you need to tell them, listen, it's very important for us to hear bugs from you. So if you really want to be in this beta, please commit to notifying us if you find any bugs. Like check this box to say, yes, I will notify you. And if you do that, you'll get a much higher percentage of people who will tell you about the bugs that they find. If you're doing multiple beta tests, which you pretty much have to, 4 or 5 cycles of beta tests, you want to enlarge the size of the beta testing community, the number of beta testers that you have with every new release. So the first release you might release to just 10 people. The next release should be to like 50 people, the next release 200 people, and so on. The reason you need to enlarge the size of your beta testing community each time is that most people will not send you feedback more than once. So even if you do 4 beta cycles, that person who told you about a bug in the first beta cycle sort of feels like they fulfilled their obligation, and they're going to stop, and they're not going to tell you about bugs that they find in the second beta or in the third beta. They might tell you if you fix their bug, but they're not really going to be, they're not going to feel like they need to do more testing for you. And so it's important to enlarge the size of the audience every time. If you can sign up, let's say 5,000 people who volunteer to be beta testers, then about 1 in 5 of them on average are actually going to really send you some feedback. And so that's about 1,000 pieces of feedback that you get. And if you can divide those up among 4 betas by giving each beta cycle, maybe 1,250 users or something like that, you'll get a pretty reasonable amount of feedback on each beta release. The most important thing about a beta test is you do not release software to beta with known bugs, especially really obvious ones. There's an enormous risk if you say, hey, it's really important to get the beta out, let's just get it out there, even though there's a big gigantic spelling error on the homepage that everybody's going to notice, or there's a big gigantic crash. Do not release that beta, because here's what's going to happen. You're going to release it to a bunch of people, they're going to see your big massive known bug, they're going to pat themselves on the back, they're going to report this bug to you that you already know about, and they're burnt as testers because they feel like they've done their obligation of telling you about bugs, and they're not interested in being your unpaid tester. And so it is a complete waste of time to run a beta with known bugs. Don't release another beta release until you get down to what we call zero bugs. Zero bugs meaning 0 known bugs. There's probably lots of bugs in there. We just don't know what they are.
French fries in the kitchen. Okay. Here, French fries. Woo!
We'll be there soon. Surprise!
Hey, Bobek. It's 4:30 on Friday.
Yes.
What does that mean?
That means, and we also are ready to ship Fogbugs 7, so therefore,
French fries in the kitchen.
Alright.
And that's it.
French fries.
More. It needs more. That's all in balance once you got. Okay, announcement. Yeah, so our goal was to ship the Fogbugs beta by today, 4 o'clock. So we made it! Yay! Well, that's what it's all about, is shipping software to customers. So congratulations to the Fogbugs team. Once you finish your beta test and your product's good enough to release, you probably have some more patches coming out there, but your software is out in the wild. One thing which is really important to do is to make sure that you find out about things that go wrong, and there's all kinds of ways of doing that. Something that I always do if I'm releasing code in the wild, or even code running on a server, is to make sure that I'm catching every crash that actually occurs. And you can do this by, depending on your programming language and your programming environment, it's usually possible to set up a system that just finds out when a crash has occurred and records at least the file and the line or what function you were in or the state of the call stack at the time of that crash, and then report it back to your bug tracking system directly.
So we've got crash reporting. It's a little program called Bug Scout that integrates with Fogbugs. And all it does is it sits around in memory, and anytime there's an uncaught exception thrown by any one of our programs. So the website has it, the Reflector has it, billing systems have it, the clients have it. Anytime there's an exception that causes a crash, it sends a little message to Fogbugs saying something crashed, and we get notified of that with a stack trace in it and everything. So often I'll be sitting, because we also have them on the test servers, so often I'll be sitting at my desk working on something, email will come in, it says, oh, something crashed on the test servers. And I'll know within about 2 minutes I'll get another case from the QA person saying, oh, got a crash on such and such page of the website. So that's been very helpful in helping us identify bugs that we have deployed, that have gotten past QA and gotten out into the wild, and just gives us a little more handle on where to start looking so we can fix those quickly.
Your product's going to be a lot better if you use it for everything internally. And some teams, this is very easy for them to do because they're making a product that they love or that they would use. So we're a software development team and we make a software development project. Great, we eat our own dog food kind of regularly. It's a little bit harder if you don't necessarily have a reason to use the product. So there were an awful lot of people. One thing that, when I was working on the Excel team, one thing Excel was really, really good at was balancing your checkbook. And the reason is that everybody on the Excel team has a checkbook, and they used Excel to see if it would work for balancing checkbooks. One thing Excel was good at, but not because of dog fooding, was actually making business models, because none of the programmers on the Excel team ever had to make a business model of anything. Eating your own dog food also means using your own product when it's not the perfect product, even if it's sort of kind of related to the need. So you may have kind of an inadequate little text editor built into your product that is sort of an auxiliary part of your product. Use that little crappy text editor when you need to write an email, and then cut and paste into your email program. Just to get the experience, just look for opportunities to use your own code and see what it feels like. I remember a case when I was working at Juno Online Services. This was a free email program that displayed advertisements. And at one point, the management of the company decided, in order to raise their revenues, that we should display 6 advertisements. When you start the program, when you check for mail, after you check for mail, when you send mail, when you exit the program. I don't know how, but they came up with 6 different places where it would show you an advertisement. And that was up from, I think, 2, start and exit. And people on the team kept saying to the management, look, this is too many, this is going to drive people crazy, we can't do this. And the management said, no, go ahead and do it. The next day, the president comes in and says, I used Juno for my personal email at home, and I got those 6 ads sent to me. It's just too much. We got to cut it back down to 2. So eating your own dog food is just absolutely crucial to realizing what experience your users are having, and you just need to do all kinds of backflips, do whatever it takes, whatever kind of contortions it takes to rearrange your life so that you can actually use your own software. One thing which I've started saying a lot is that software is a game of inches. It's like fighting for every single inch in making the software better is what makes a product that delights people all the time. And when they discover one of those little tiny things that you got right, that, and it showed that something that they didn't feel like they're likely to spend a lot of time in, but you put a lot of effort into that particular area, that's what makes people really delight in the software. So I'm just going to call out a few little examples of that in FogBug 7, which probably most of them are so small you didn't notice them. Some of them are a little bit bigger, but these are the kind of things that make FogBugs a really, really great application. There was an example of we have little tooltips on the bug entry page. And when you hover over each of the little fields, you got a little tooltip, except for the new tag field, which we forgot to put one in for that new one. But luckily, Allison noticed that and called that out. And now we have a tooltip for all our fields. I don't know if you know this, but right now, as people are going to Joel on Software and reading about the new FogBugs, they're all hitting try.fogbugs.com and setting up accounts, and there'll probably be a couple hundred new ones by the time we get back to lunch. And for that purpose, without anybody even telling them, Michael Gorsuch and Sean have set up a bunch of new servers that are fresh and don't have any load on them whatsoever. So we'll be able to deal with the launch in a way that is hopefully respectable, so we don't get all kinds of snarky stories about how we should fix our own bugs before reporting or whatever, things that bloggers will say about us. I don't know if you've tried to sign up for a trial account, but you should all sign up for a trial account because a process that used to involve 2 confirmation emails where you had to click on 2 links in the email and lots of pages of forms and stuff that you had to fill out, and it took a long time. And it warned you that it was going to take 48 hours and so on and so forth. It's now totally streamlined, it's extremely painless, and it has this incredible thing I've never seen anywhere before where there's actually 2 parallel processes going on. You're doing your work to go read your email, check the confirmation email, and at the same time, we're actually creating your account in the background, and we're showing you this in an elegant way, and it's pretty friggin' awesome for something that every customer sees at most once. That's just the administrator sees it once. And the effort that we put into these things that everybody sees once is exactly the Fog Creek ethos of fighting for every inch, fighting for making every single inch of the product absolutely friggin' beautiful. So grab a champagne or whatever you got there, a bubbly apple juice or something, and join me in toasting FogBugs to FogBugs.
shipping is the equivalent of commencement for software, because it is graduating from being this thing that you have spent the last 8 months, 3 months, whatever your development cycle is, working really hard on, trying to perfect as much as you can. That includes showing it to some users, but it's not generally released out there. And so you've built up this story, this idea about how the software is going to work, and then you actually have to put it out there and let customers try to use it.
It's really, really rewarding to see something that I can claim at least partial credit for coming up with why we're doing this and seeing it shipping and people liking it. And that it's just an amazing feeling of having built something people care about.
Knowing that you've solved somebody's problem is a moment in every software developer's life that is that's crystallized. Even as you move on to the next project, you go back to those moments where you're like, wow, I can't believe that one. Don't you remember that one customer who was like, hey, you guys actually really nailed it here. That's the energy that we take into the next version of our software.